Congruent figures. Congruent figures are polygons that have congruent corresponding parts. That means that their matching sides and angles are congruent. So here we have two triangles with various side markings and angle markings. So let's go ahead and identify the corresponding angles. So the corresponding angles are the ones that have the same number of arc markings. The two angles in the two triangles that have one arc marking are angles A and J, and those are congruent to each other. The corresponding angles that have two arc markings are angles B and K, and they are congruent to each other. The corresponding angles that have three arc markings are angles C and L, and those are congruent to each other. We can take that same idea and match the corresponding sides. So the two sides of the triangle that have one tick mark each are segment AB and segment JK. Those are congruent to each other. The ones that have two markings each are segment CA and segment LJ, and those are congruent to each other. And lastly, the ones marked with 3 each are segment BC and segment KL, and those are congruent to each other. Now once you have one polygon that has all congruent and corresponding sides and angles to another polygon, we can write a congruent statement. And our congruent statement for these triangles would read, triangle ABC is congruent to triangle JKL. Now the order of the vertices is extremely important, and an easy way to remember it is that you have to have the corresponding ones in order. So if we have ABC, look at the angles, A, B, C, so then the second triangle has to be listed in that same corresponding order, J, K, L. You could have written it in a different order as long as the first two vertices are corresponding, the second ones are corresponding, and the third ones are corresponding. Now let's get into a little bit of practice. So without a diagram, if you're just given the congruent statement, triangle WRD is congruent to triangle PLK, they're asking us segment WR is going to be congruent to which segment. So remember, I said that the vertices are in corresponding order, so if we're talking about segment WR, that's the first two. So that's going to correspond to that same order, PL. So we have segment PL. In the second one, again, we have a congruent statement. Triangle PMC is congruent to triangle LDX. Then it says angle M is going to be congruent to which angle? So angle M is the second vertex, the second angle. So we're going to go with the second one, the corresponding one, angle D. And then lastly, if we're given a congruent statement, triangle RHK is congruent to triangle WVO, then triangle KRH. So this is what I was talking about when I said you can rearrange the letters in the triangle congruent statement as long as they're in the corresponding order. So the first one we put was K, which is our last one here. So we need to put the last one first. So we have we start off with triangle O, and then next is R, which is the first one, so we need to write the first letter, W, and then we finish with H, which is the middle letter, so we write the middle one, V. So remember, you're just following along in that same order. So I want you to go ahead and pause, try 4, 5, and 6, and check back with me when you're finished. So for number 4, you should have gotten segment QM because PS is the last and the first, so QM is last and first. For number 5, angle T is the third one, so you have to correspond that with angle N, the third one. And then when you're rearranging the triangle congruent statement, CJX, so you went middle, first, last, so follow that same order, middle, first, last. And you should get triangle WMP. In this example, we have a diagram, and it tells us that triangle MKL is congruent to triangle JET. And it asks us to complete each statement below. So before we get into filling in our statements, I just want to take the congruent statement and mark our picture. So we're going to mark the corresponding angles and sides with the congruent tick markings and arc markings. So at angle M is congruent to angle J, so I'm going to mark each of them with one arc. Angle K is congruent to angle E, so I'm going to mark each of those with 2. And then angle L is congruent to angle T, so I'm going to mark each of those with 3. Now I can tell very easily looking at my picture which angles are congruent to which angles. And we can do the same for the sides. MK is going to be congruent to JE, so MK and JE are both going to get marked with 1. KL and ET, so KL and ET. And then lastly, LM with TJ. So here's LM and here's TJ. Now we can start to fill in our statements. It says segment MK is congruent to what other segment? MK is marked with 1, so we find the other segment marked with 1, and that's segment JE. Number 2 asks us, angle L is congruent to which angle? So angle L here is marked with 3, so we find the other angle marked with 3. And so angle L corresponds to and is congruent to angle T. Now when we look at number 3, it's a little different than number 1, but it does look very similar. Number 1 has a segment line above the 2 letters and a congruent symbol. Number 3 does not have a segment line and it has an equal sign. So if you think back to the beginning of the year, we talked about how when you have 2 capital letters right next to each other with no symbol above it, this actually stands for the length of segment ML. So I want to know how long is the physical length of segment ML. The only problem is we don't have the measurement, so we need to look at the other segment that's marked with 3. So over here, JT is also marked with 3, meaning they're congruent. So if JT is 6 centimeters, that means ML is also going to be 6 centimeters. And then when we look at number 4, it's the same idea. We want the measure of angle M. So we're not asking for what angle is congruent to it. We want the actual measure. So we want a number. So if you look at angle M, again, we don't have an angle measure, but you know that it's marked with 1, which means it's congruent to angle J, which is also marked with 1. So since J is 85, M is going to be 85 degrees as well. So then, number 5, this just mixes up our triangle congruence. It says triangle ETJ. So we can go back to this one, or we can look at our picture. The order ETJ, if you look at the arc markings, we went 2, 3, 1. So you want to follow that same order, 2, 3, 1. So we go KLM. So we're going to put triangle KLM. And then lastly, we need to find the measure of angle T. Now, we don't know what the measure of angle T is, so when you look at the corresponding angle, angle L, you actually don't have a measurement for that either. However, you know that angle K here is 32 degrees, and that's marked with 2. That means that angle E, also marked with 2, is 32. Now we run into this situation where we have 2 angle measures in a triangle, and you're just missing the last one, which is the one we need. And if you remember from our previous lessons, we know that the interior angles of a triangle add up to 180. So x plus 85 plus 32 equals 180. And all we need to do is solve that equation for x. So 85 plus 32, that's going to give us 117 plus x equals 180. Now to isolate x, we want to get rid of this, so we want to subtract 117 from both sides. And then we have x is equal to 63. So that means that angle x, which is our angle T, which is what we are looking for, is 63 degrees. Lastly, we just want to talk about a theorem called the third angles theorem. And it says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. And what that's saying in this diagram is here we have two different triangles. And we have that angle A is congruent to angle J, and angle B is congruent to angle K. So even though we don't know the measurement of angle C and we don't know the measurement of angle A, we know that those are automatically congruent to each other, and we can mark them with 3 each. And the reason why is because you know that the angles of a triangle have to add up to 180. So again, let me just give you an example to help reinforce this theorem. Let's just say that angle A is 30 degrees. That means that angle J is also going to be 30 degrees because those are congruent. If angle K happens to be 100 degrees, then angle B also has to be 100 degrees because they're congruent to each other. So far, we're just working with the information we have. Now, I want to solve for the measure of angle C and the measure of angle L separately. So in this triangle, we have 30 plus 100 plus the measure of angle C equals 180. So then we have 130 plus the measure of angle C equals 180. So then when we subtract 130 from both sides, we get the measure of angle C equals 50 degrees. Now let's do the same math work with this triangle. We have 30 plus 100 plus the measure of angle L equals 180 degrees. 30 plus 100 is 130 plus the measure of angle L equals 180. And then when we subtract 130 from both sides, we have the measure of angle L equals 50. So just as we had suspected, the measure of angle C and the measure of angle L are congruent because they're both 50. So just let this be an example that shows you that if two different sets of angles of one triangle are congruent to two of the other, then the third angles have to be congruent. And again, this only works with angles because each triangle has to have 3 angles that add up to 180 degrees. That's it for this set of notes.